Homer Electric Association's Battery Energy Storage System, or BESS, is an innovative project that allows HEA to increase system efficiencies and provides improved reliability, among other benefits. There are three basic reasons for installing the BESS. They are, first, to provide spinning reserves, second, system frequency and stabilization, and third, potential integration of non-firm renewable power generation. Come along on our walk throughout the BESS and learn about this exciting new project. HEA is not the first railbelt utility to see the value of a BESS. In 2003, Golden Valley Electric Association, located in Fairbanks, Alaska, was the first utility in the state to adopt battery energy storage and, at the time, had the most powerful BESS in the world. Like Golden Valley, HEA's BESS project will provide additional grid stabilization when moving power north from the Kenai Peninsula to the Anchorage area and beyond, a long-term benefit to the railbelt utilities when they're connected to our BESS. HEA's BESS includes 37 Tesla Megapack battery units weighing in at 52,000 pounds each. The BESS can store up to 93 megawatt hours of energy and can deliver this at a rate of 46.5 megawatts per hour directly to HEA's 115 kV grid. Tesla's Megapack, introduced in 2019, was specifically designed for large-scale storage to better meet the needs of utilities. In late 2019, HEA agreed to purchase 37 Tesla lithium cobalt Megapacks at 1.25 megawatts or 2.5 megawatt hours each from Tesla. To help put this in perspective, 37 Megapacks equates to just over 1,300 Tesla electric vehicles, or EVs. HEA's BESS is currently the largest battery storage facility within 2,300 miles. Total facility investment is just over $40 million. These batteries arrived at HEA's Soldotna Generation and Substation facility in July of 2021, and after extensive testing, the BESS was integrated into commercial operation in January of 2022. The BESS includes an integrated heating and cooling system to keep the batteries at their optimum temperature. To further increase their longevity, HEA plans to avoid fully charging and discharging the batteries under normal operation, since that causes excess heat, which leads to battery degradation. HEA plans on running its battery at a charge level between 70 and 85%, so that we have near maximum ability to provide power to the system without impacting the life of the batteries. In 15 years, the batteries should be at 87% of their original capacity, versus 70% if the batteries went through daily full charge and discharge cycles during that time. Many different HEA departments worked on the BESS installation. Our engineering and generation departments designed and managed the installation of the project. Our finance team was instrumental in helping HEA finance and pay for the project. Another significant part of the process included protecting the BESS from cybersecurity breaches. To safeguard the system from potential hackers, HEA invested hundreds of hours into implementing cybersecurity measures and high levels of security protocols. Once the BESS was commissioned, our operations team managed the BESS. With fuel savings approaching at least $1.5 million per year and the additional savings anticipated from integrating a few renewable resources, we're expecting the economic savings to exceed our capital investment over the life of the project. In addition, the frequency stabilization benefit of the BESS will improve power quality in a manner that most members may not appreciate. However, our local refinery, one of only 2 in Alaska, does recognize the value of improved power quality in their operation. HEA is one of 5 Alaskan railbelt utilities that share energy with one another to lower costs and improve reliability. However, HEA's connection to the railbelt is tenuous, with only one transmission line connecting it to the railbelt electric grid. Routine maintenance severs the connection on this tie line every year, electrically islanding HEA, forcing the utility to be fully self-reliant until the connection is restored. Maintenance typically lasts 1 to 2 months. However, other circumstances can island HEA for longer periods. In 2019, routine maintenance and the Swan Lake fire islanded HEA for 176 days, or almost 6 months. The Swan Lake fire drove home the need for technology that could improve HEA's reliability without burning additional fuel. When islanded, the natural gas costs alone increase approximately $24,000 per day in additional fuel. The BESS limits these additional fuel costs when HEA is islanded from the grid. It is clear that the BESS has expanded HEA's capabilities. Let's examine the three primary reasons for installing the BESS on HEA's system. First, spinning reserves. To generate electricity reliably, utilities use spinning reserves, which are extra generating capacity that's available but is not necessary to meet the current load. Spinning reserves are vital to ensure power remains reliable if load suddenly increases or if there is a loss of a generation source. Typically, HEA has to have at least 3 power sources to run the system reliably. These are our combined cycle plant, the Bradley Lake Hydro Plant, and a third natural gas unit. However, if we can use the battery as one of those 3 units, then there's no need to burn any more fuel when the system is islanded. HEA will see significant cost savings by using the BESS instead of a natural gas-fired unit as its third power source, as well as improved system efficiency for HEA year-round, serving as regulation as well as spinning reserves. The second benefit is frequency and stabilization. Our focus is on regulation, which is the combination of frequency and stabilization. Stabilization is allowing the system to respond automatically to frequency deviations, which is where the challenges begin with non-firm renewable resources. The BESS will respond to frequency deviations much faster than our gas-fired units or hydro facility. It probably goes without saying that such a small grid as the one we have along the road system in Alaska is much more sensitive to frequency excursions. In effect, these are load changes, generator trips, or transmission interruptions than a much larger or more interconnected system like that in the lower 48. A good analogy is like riding a skateboard compared to riding in a car. On the skateboard, like a small grid, you're much more sensitive to bumps in the road or unexpected changes in conditions. And third, integration of utility-scaled non-firm renewables and energy diversification. The BESS has already created system efficiencies across the rail belt, but the Megapack installation provides a great side benefit of opening the door to incorporating renewable intermittent energy projects that would have otherwise stretched the capabilities of our current thermal generation assets. Another key application of the BESS is it allows HEA to pursue renewable energy projects and diversify its energy generation sources. The HEA Board of Directors has long embraced renewable energy and currently aims to achieve 50% renewables by the end of 2025, the same goal set by the Alaska Legislature for the state. Currently, HEA receives about 85% of its power from natural gas and 15% from hydropower. While hydroelectricity output can be controlled, wind and solar energy vary from day to day and minute to minute. Regulating renewables that are unpredictable by nature is challenging. HEA's BESS can go from zero input to full input in 1/10 of a second, and it can regulate faster than any thermal or hydro unit. So it gives you a world of capability for renewable power that HEA would not otherwise have. The challenge of integrating non-firm renewables goes up as they become a larger percentage of the load serving resources. However, we are seeing some independent power producers, or IPPs, designing projects that reduce the regulation burden. Their design changes, along with the BESS, should help reduce these challenges of integrating non-firm resources onto our system. In short, the BESS gives HEA the opportunity to actively pursue innovative renewable energy opportunities like this that have the ultimate result of energy diversification and the potential for lower generation costs. After considerable attention and time, HEA is pleased to announce the completion of this very successful project, and we are proud to introduce this major step forward in our renewable energy goals. HEA will hold an in-person ribbon cutting and tours for the BESS in the fall of 2022. For now, we hope you enjoyed this virtual walkthrough of the BESS. For additional information on this and other projects, please visit us online for more information.